Let's continue our discussion on ensemble learning and random forests. Specifically, we want to discuss stacking. Ensemble in general reduces variance and increases accuracy, especially when using decision trees as base learners. Ensemble models generally win online Kaggle competitions even to this day. That's why ensembling is very popular. Bagging in particular is robust against outliers. Boosting is flexible and can be used with any loss function. So you should pay attention to the difference among those two so that when you actually use those methodologies, you know which one could potentially do better on the specific data sets that you have. However, without careful pruning of the trees, ensemble methods will take longer to run than a single classifier and will be harder to interpret than a generalized linear model. Just because you have hundreds or thousands of decision trees, and then the conclusion is much harder to be explained. Finally, a third type of ensemble has been gaining favor that's called stacking. This ensembles a diverse group of strong learners and trains a second level meta-learner to learn the optimal combination of the base learners. This is frequently used in conjunction with neural networks. So let's look at what exactly is stacking. It's also called stacked generalization. Instead of using trivial functions such as hard voting to aggregate the predictions of all predictors in an ensemble, why don't we train a model to perform this aggregation? That's really the whole idea. If we have multiple models, can we train a model to leverage the output from all the different models that we built? Let's look at specific examples. So suppose that I have a new instance, and then I have three different models. In this case, three different regression models. And then the first model comes back with 3.1 prediction. The second one comes back with 2.7. The third one comes back with 2.9 for this new instance corresponding prediction of y. And then question is, are we able to use some sort of blending or a new model to come back with a predictive value of 3.0? So remember that when we said in the hard voting mechanism, what you do is instead of doing having a new model, you would have some sort of average of those predictions to come back up with a conclusion, right? So in this case, we have a new model in between to come back with a prediction. Let's see how we can use this stacking mechanism in some examples. So suppose we have this training data set, and then we split the data set into two subsets. You will see why we want to split that very shortly. And then the first subset is used to train the predictors in the first layer. So we use this subset to train different models and all different predictors. So that this might be a support vector machine regression, and this might be a decision tree regression. This might be a linear model regression, and then that's our three predictors or three models. We're going to leverage those three models and subset 2 to come back with the next level of model. So for each instance in the holdout set, which is subset 2, we have two subsets. We use the first subset to build those models. Now we're leveraging subset 2. For subset 2, since we already have three models, we apply these three models on subset 2 so that we have a prediction. for each one of the observations in the dataset of subset 2. Then we have 3 predictions for each one of the individual new instances that's in the subset 2. For each one observation, we have 3 different predictions. And then for all the observations, we would have 3 times of those predictions, right? So that this would be our predictions of the subset 2 based on diverse predictors or prediction models. So what we do is we create a new training set using these predicted values as input features. And then which makes this new training set to be 3-dimensional just because we have 3 different predictors. You could have 5, you could have 10, right? So for each individual observation, you would have 3 different predicted value. Of course, for all the observations, it will 3 times all the observations. So what it does is the blender is trained on this new training set. The predicted value would be our input. And then you're training on that predicted value to come back with a new blender that comes back with a new predicted value. So the blender is trained on the new training set, so it learns to predict the target value given the first layer's prediction. These are the first layer prediction. You're trying to learn a new blended model. It's called blender. So this methodology is called stacking. This whole process is called stacking. Of course, you could even leverage multi-layer stacking. What we just discussed is just one layer. You can even leverage multi-layer stacking. Of course, if you are going to use multi-layer stacking, you have to have multiple subsets. This is just an illustration on the right-hand side of the multi-layer stacking ensemble. Unfortunately, scikit-learn does not support stacking directly, but good news is you could use something like ds630 to work on multi-layer stacking. This is something that you can explore if you are interested in this topic. Okay, here is really the key takeaways for ensemble learning and random forests. So we discussed majority votes, basically hard votes versus soft votes. And we discussed bagging and pasting. Bagging and pasting are based on different samples. We discussed boosting. Specifically, we discussed ADA boost and gradient boosting algorithms. We also discussed stacking. Just pay attention that for bagging and boosting, we're still using the same type of model. We didn't change any of the type of models at all. It's just you have a decision tree, you build upon new decision tree, continue with another decision tree, either by different sample or by some sort of weak learning, correcting the weak learner's weakness, right? However, in stacking, you can see that we use different types of models. For example, it could be SVM, it can be GBM, etc., etc. And also another key takeaway that you should be aware for this section is random forest is an ensemble of decision trees, generally trained via the bagging method. Okay, I hope you actually get a fairly good understanding of ensemble learning and random forests after this section. Thank you.